Hello and welcome back to another episode of Learning Rust with GoodObject. Hi Sid, good to have you back after the weekend.
Hi, Sebastian.
And I think before the weekend break, we were looking at error handling crates and talked a little bit about how error handling can be done in Rust and that you need additional crates to implement the error trait for you, which is what you want when you want to have causes or error chaining and backtraces. And if you want to have any crate interoperability, if you're doing an API crate that provides a library, you definitely have to implement error for your error types. And then you want to use one of these many crates. Is it going to be anyhow or not? And that's what we dive into, like which crate to use for what. And it's just a selection, but it's a selection that I think represents the current trend in the Rust ecosystem. It's a la mode or fashionable, maybe, or just downright the best that we have right now. All right, for that, for the first time, starring GoodObject, which, after all, is what we're supposed to be learning with here. And here it is. We have prepared 3 files to look at with 3 different kinds of error crates and ways to deal with errors. And this one here is in GoodObject, which deals with encoding and decoding of good objects. And it's a library crate, so there's no binary here. There's not an application, but it's something you can use to build application. It's a building block, if you so will. And I mean, you don't see anywhere here. So if we look at, let's see, is there this error that I'm seeing here? Where is this even used? So it is actually something that is stuffed into an IO error. So probably it's not used directly here, but just as part of some IO operation, as you can see here, which is also an interesting use case because this is something you have a lot, that you do IO on your custom types, but when you do that, then IO error is the way to go. And in order to create your own IO error that is a bit more specific or carries more information, you do it just like that. You say std IO error new, then tell which kind of IO error it is. In this case, it's always other, which I do have a story to tell, but in the interest of time, let's just say other is what you use, and it was always like that, and nothing ever will break your code again with this. Just use this. And you just plug in any kind of thing that implements error. And I think this highlights even more why it is so important to implement error, because otherwise you're not really compatible with anything else that is doing error handling. So you need to implement the error trait. And you can do that by hand. And some authors, they do that by hand because it's, maybe they're a fast typist or they really like typing this out. I mean, it's fun to type sometimes. If you have an editor that is faster than IntelliJ or one of the many JetBrains products that are always kind of sluggish, no matter how fast your computer is, at least for me. But, this one here is the quick error. That's the lightest error crate I know, while still giving you a lot of convenience. So I think this is just, let's see, implemented in 1,300 lines of code, just a single file, and it's basically just a big macro here, lots of documentation as well. So that's just a macro that auto implements a lot of things that you would otherwise have to implement by hand. So it is kind of creating its own little syntax here, right? This looks a bit like an enum, but it's not really an enum. Like, no. But it's something you can memorize, and with that you can, well, just create an error type that actually is an enum that you can match on. So this is useful for callers of you who want to figure out exactly what happened. Yeah.
And this, okay, so this just gets rid of the boilerplate then essentially. So instead of just typing it out yourself, it kind of does that in the macro. And I'm guessing there are limitations to this as well. You know, light crates or stuff like that usually have those, but
yes.
Okay. So for certain use cases, it's very good to use.
It's kind of my go-to, because if you can live with the kind of way of specifying this and maybe some weird macro-related errors if you get the syntax wrong, like then the error that you get is probably less easy to understand than, you know, if you use a crate that doesn't use such macro magic here. Not a problem for me, and this can do much more than just displaying, you know, implementing display here. It can also implement conversions from, for example, it can implement sources, so it can have this error chaining automatically set up for you. It's pretty neat for what it does. It compiles in 0.3 seconds or so. It's really fast compiling. And that was what I remember from some low-level Intel Core CPU. So it's my go-to thing. Compile times is always something I think of when I think of Rust as well. So you don't want to just pull in everything. It should take some thought. Yeah, that's that. And it's that easy. I think it's quite readable too, quite maintainable. And this is how you can have specific errors for pretty much anything that goes on in your library.
Then one more question about this IO error, because you're essentially stuffing your custom error into this IO error, right? So this it's wrapping your own type or your own error type. And that is essentially what you mean with chaining, right? Then the one error knows about the other error and it can kind of get the context from it and just display a more accurate thing.
Yes, in theory that would chain, but this one is not chaining. It's really just a shell, so to say. So if you have to return an IO error because the API enforces this, like the many IO related traits, then that's the only way of making this your own or carrying some of your own error information.
I see.
But the typical IO errors, of course, they are already represented by the standard IO error. So could not write file, this or that, directory not found, file was a directory, can't write into this kind of stuff. So there's no chaining here because there's literally nothing else that is known. It's more like what happens here. Like we try to parse a header field, and if there's nothing in there, we say it's an empty value, which is our own error type. But question mark will convert that into an IO error, which it knows how to do because we have implemented from our error for an IO error. Standard library IO error. Yeah. And that's all it takes. Let's see one. Let's put that to the test. Let's run the test here. Everything builds and runs. You don't see that it's off screen. Let's see. And now if I would temporarily deactivate that, we'll probably be greeted with a nice with a nice error here that says cannot use the question mark operator because it's not in. You can't transform into an IO error anymore. And this residual thing, I don't know where that's coming from. It's really, I have to look into this. I don't know what happened there. That's probably something new and fancy. It's always good to know more. Yeah, but I think that's a nice simple example on how you use this. And my recommendation really is to use quick error. It's also maintained still, so I have contributed to this crate a little bit just to keep it up to date with Rust and move it with the times. So I think now it's good. It's version 2.0 by now. All right, then moving on to this one. No, not this one. Maybe this one. Yes. Okay, so here we are in Git repository. That's a higher level crate, but it's still a library crate. And as a higher level crate, if we would look at its cargo file, which is here, you see that it depends on basically all the plumbing crates. It pulls everything in because it's a hub. It just makes everything that is Git Oxide available under one namespace, and it takes all the plumbing crates and puts it into a nice API. But if you want to still access them, some types from there directly, which is encouraged even, then you access it through Git repository. This is why you see this here. This also means that basically Git repository pulls in a ton of dependencies. Like there's no reduction of dependencies anymore, not to that extent, because you just need that much if you want to be the hub for Git. And some of these dependencies here, they use a different kind of error handling library that you also should know about. So it's still API level, but it looks a bit different. And this is why Git repository uses this better library. So not quick error anymore, but another error handling library that is displayed here. So this easy ODB refresh error, you see this namespacing here. I love namespaces because, as opposed to names can't be shortened. So if you want, you can import a name, you can just import this, and then you have refresh error. Depending on your context, this is unique enough. This is non-ambiguous. This is clear what it is. But depending on that, you can then shorten your name. That's why I love namespace and prefer them over anything else. But that's just a side note. So this is what you see a lot here in the GitOxide code base. And this error, look, it even has its own little module just to have this namespace going on and declare a little bit more what it is about. Just created for this purpose. Also something I do. So usually most of the methods that you can call, they have their own error type because they have own failure modes that are unique to that particular method. And this makes error handling very, very specific, and you can always figure out what it was that failed. And that's the purpose of this error. So it's literally called this error, the crate. And this error is also a macro, but it's a fancy macro. It's a derived macro. And derived macros are procedural macros that are actually plugins to the compiler. And that's fancy because now at compile time, the compiler loads you as a plugin and gives you a stream of tokens. And the stream of tokens is basically this here that it parsed for you into tokens. And then you can take that token stream and manipulate it and create a new token stream that is the new code. So it's code generation, essentially, but user-defined at compile time. And these crates, they have a lot of boilerplate because all of a sudden, this token stream you actually have to handle, manipulate. That's something that other crates do that are pretty big themselves. So whenever you have a procedural macro like this, your compile time goes up 10 seconds, at least. Unless you are on an M1 or M1 Pro, then it's probably less. But
always bragging.
Yeah, it's a game changer. Right now I probably would care less about that, but previously I did care a lot about that. And this, of course, stays in my memory, so I will always care about that because I know it's just, if you don't need the features or the syntax, then don't have it. Use quick error. So the syntax is essentially just like this, right? It's using these attributes to say what you want with the error or to have kind of your own display messages. Here, these errors are really just passed through because it's more like a hub for errors. This thing doesn't have its own errors. It's just that the calls it makes can generate these errors here. And this is what transparent means. And one of these errors here, the ODB linked init error, I think that's that's also one of these. Also both transparent. Let's see if we can get to some that actually is its own thing. So you see this tree of calls, like I call you, and you can fail this way, and this is how you have a tree of errors all of a sudden. So it's kind of a complex thing, but still you can perfectly see what failed exactly and where. And here we go. Here's the first, this error that formats a display string here. So that's for display. And you see there's special syntax here to access the values in that particular variant. And that's essentially it. Plus support for generics. And that's a major benefit over quick error, which does not support generics. Otherwise, it's just syntactically different.
That is pretty cool. So you really just build your own structure essentially of errors, and then they all depend on each other. So yeah, like you said, it's kind of this chain going down.
Yes.
And at the base, there will always be, you will have some kind of end condition that then actually displays it, what's going on.
At some point, there should be known what's going on, and this is when you probably provide some context about it. But these things, by the way, these are then error chains. They're like whenever there is a from, this is automatically chaining this. So if it converts into some transparent error, oh no, wait, I think that's actually not, this is the purpose of transparent. I think transparent does not chain them. So it's just like, this is not actually there. So you don't see, oh, this, because that doesn't actually add value here. This doesn't really add context. It's more like a structural thing that you have to do. And that's another benefit, probably the main benefit most of the time for this error, that you can have these transparent errors that are just aggregations that are itself not really there. Because when you do the same for quick error, you're forced to set a display message. You're forced to say something, which you can do here. You can say something which provides context, but most of the time you have nothing to say. Like it's just some general yada yada, which doesn't help ultimately. So going back to this one here, look, refresh object database. I get a mutable repository. This can fail. And then I refresh an object database that can fail. So what kind of context would you be talking about? You know, like this is already part of what the low-level error is here. So being forced to write a nice message here really doesn't help. It's only overhead for you, and it can't be useful. Like I could not get the mutable repository that I need to refresh the object database. You could write that, right? Because that's the context. But also, let's say it's something you probably would do at the very end to fine polish this, or if people run into certain errors a lot, then you would probably start to provide more context to help if you get issues all the time related to error handling or error messages not being clear enough. But it's part of the API that I would flesh out as there is demand, because you don't know yet what kind of errors commonly happen when people use this. Unless you know.
So this is more like a building block for you, essentially, to keep it structured and to have everything flow in the correct direction, essentially. But it's not something the user actually ever sees.
Yes, exactly. This is just structural. And it allows you to provide context, but I would only do this when needed or when there's indication that you need it. And this is the benefit over quick error. Also, it's easier to write. IDEs will be have an easier time to guide you with syntax, because this is just a normal enum here. And all these attributes here, I mean, they're special, there's no help. But if something goes wrong there, then the error message will be very clear, because yeah, it's Rust code behind that can be as good as it wants to be, whereas this macro magic stuff, it has great limitation when it comes to error handling. Yeah, and that's the next thing. So if you have in your dependency tree this error already, then definitely use it. And this is why Git repository uses this error. It's just nicer and easier to handle. Yeah, or if you have the budget for your build time, also fine. Right. Now, where's anyhow? One might ask. And anyhow is only to be found on application level. So we have pack create here, for instance, that is in the Git Oxide core crate. Already folded this in because there's this big undocumented create function that is literally pack create here. And it doesn't have to be documented yet, because it's really just there so that the command line interface, the CLI, can use it. or potentially other applications that want to use GitOxide core functionality and build stuff into their own kind of interfaces, right? This is why GitOxide core exists. But GitOxide core is high level. This is for applications. And thus here we stop having this fine-grained access to every kind of error that ever happens in the call tree of everything. This just says anyhow. There's an error, and the tree, of course, the chain, the error chain, will be maintained by anyhow, right? And with anyhow, it's really easy to also add context to that. But it's also really easy to simply not care and just say question mark here, question mark there, and you're good. And that's exactly it. So this whole overhead of having to define your own errors, on this level, it's not there anymore. So application writers, they would not do that, but they would potentially use the capabilities of setting context like this to just add your own context to any kind of error that can happen here. So this is how this works here. So as you can see, this context is a little bit like having a custom error with a custom display message. But this is not an error that people can still differentiate in code. This is just for the user, just so that they see some more information on why stuff goes wrong. And that's the differentiation there. Easier to use. And again, I guess my credo is on-demand context, because I don't know where it usually fails until I use the software a lot myself, or people use it a lot. So not quite there yet.
So in terms of performance, you said that also kind of adds a lot, right? That's quite a big library, but you couldn't really compare it to this era, I guess, right? Because the use case is so different.
Yeah, it's a different use case, exactly. And you would, I mean, this one, let's see how the type is created. So this is are we in anyhow? We are in anyhow. Core result. This core, oh, that's Rust core, okay. TE, where E is error. Okay, so this error is probably an anyhow error. And now we see how it is. So it's an owned with a pointer. So it already tries to optimize things if it goes with null T. There's already some magic going on. Probably with some unsafe code somewhere to save a few bytes in representing the error impl. Look, it goes down to direct vtable stuff. It says this is a static lifetime, which usually means that it heap allocates. Like static lifetime you only get on the heap. So it probably creates, moves these error types onto the heap, and then, does some magic stuff there in order to get this vtable to still get access to that error. Yeah, here. So it already is a low-level library on its own, and it does it as good as it can, but it's definitely more than what you would just more overhead, right? With this. This is an allocation, probably most of the time, I don't know, probably most of the time. There's more overhead than what you would get with the quick error or this error. And is it prohibitively expensive? The question is, depends on the use case. This error type is definitely larger than what a small error enum could be, or what a unit error could be. We can have just unit that is just, a message or something. Of course, this is bigger, and that might affect the compiler's ability to inline code, or it might just, push certain things out of a cache line because now your stack grows larger and then your CPU has to shuffle more data in and out. These kind of things, size affects the runtime of performance critical code, and error handling can affect it, but depends on the use case, depends on so many factors. It's just a rule of thumb, I guess, to not throw anyhow into a library and call it a day, because there are alternatives that are just better. And to my mind, it's really useful to think in a structured fashion about your errors, especially in low-level crates that people are supposed to use as building blocks. It's just helpful to make everything better. But here, it's nicer to focus on actual, you know, getting stuff done quickly. Sorry?
Yeah, absolutely. I agree.
Yeah.
Like it's more about making, not worrying about these things because it's not necessary. You want to write the actual code quicker than to worry about all your types and stuff like that. It makes sense.
Yeah, yeah. And it's nice that you have the option. You have the option. You have a choice, and now I think you know how to make that choice or how to make these decisions. It's quite nice because you're not forced into one way of doing things or another way of doing things, and yeah. But never ever roll your own error type or ignore what's there. People will not like to use your software then. Unless it's an application, then you don't care. Or you say anyhow. And that might be a good time to say, yeah, this could be our session for today, because that's really it about error handling in Rust.
Absolutely. I think it feels like I do have a better choice now, a better idea of what's going on. And that's all I needed.
Cool. Glad it was helpful. I hope it was helpful to our audience as well. And maybe we see you next time. Bye-bye.
Bye.